This video will cover GIS, which forms part of the geography syllabus. GIS obviously stands for Geographical Information Systems. There are a number of key terms associated with GIS that you are required to know. Remote sensing is the collection and interpretation of information about the Earth from a distance. Sensors measure wavelengths of electromagnetic radiation according to the electromagnetic spectrum. Everything on the Earth absorbs and reflects light differently. You can get multispectral, which measures many segments in the spectrum, panchromatic, which measures the wavelengths in the visible spectrum, radar or microwave, which detects Earth's features by bouncing radio waves off the features. This can occur at day or at night and when there is any weather. And if we look at satellites, rockets launch satellites into space to orbit at various heights. Polar orbiting is between 500 and 800 kilometers above the Earth. It takes 99 minutes to orbit the Earth. It's also known as low orbiting. A common thing that everybody uses is GPS, which is taken from a QuickBird satellite by the name of QuickBird, obviously, and it is an example of a polar orbiting satellite. Then we look at geostationary satellites. These are 36,000 kilometers above the surface of the Earth. They hover over one object and coincide with Earth's rotation. An example of a geostationary satellite image would be the meteostat weather satellite. So a weather satellite image that you see of a whole continent at a time or whatever, and it's often a very coarse image. Then if we go on to types of resolution, spatial resolution refers to the scale or level of detail of the data, i.e. is it regional, national or global. Spectral resolution refers to the range of wavelengths or bands that an imaging system can detect. Temporal resolution refers to how often the image is taken and for how long the image is sensed over time. It's the period of image capture. Then if we look at resolution, we either get a high resolution image or a low resolution image. Very easy to understand. High resolution image, smaller pixels, more pixels and a greater image quality. The individual pixels cover a smaller area. If we look at a low resolution photograph, larger pixels, fewer pixels and a worse image quality. The pixels often cover a large area. The image is often seen to be pixelated. Then if we look at a remote sensing specialist, this is a person who uses remote sensing to obtain an image and process it spatially and spectrally, then analyzes the image and sees what it has to tell us. Then if we look at passive sensing, this detects naturally emitted signal. If we look at active sensing, it emits signals and detects the reflected signal off different objects. Then if we look at small scale and large scale images, obviously a small scale image covers a larger area, whereas a large scale image covers a smaller area. So they're the opposite of what you think. Then if we look at low angle and high angle shots, a low angle shot, an easy way to remember low angle and high angle shots, a low angle shot has a smaller angle than a high angle shot. Please note, in a high angle shot you can always see the horizon. Then if we look at spatial and attribute data, please note this is one of the most important parts of GIS and one of the areas where they like to test on. Spatial data is geographical data which describes the location and geometry of certain objects. Spatial data is stored, managed and transferred. So an example of this would be the actual base map that you use. So in GIS, OpenStreetMap is an example of spatial data. It is the background map that you use before you go and input your attribute data. Then moving on to attribute data, this is tabular or textual data which describes geographical characteristics or non-spatial information of certain features, i.e. the names of features, lengths of rivers maybe, the order of features and the type of features. So, like categorizing them into rivers or dams or oceans, etc. Then if we look at vector and raster data, this follows on from our spatial and attribute data. Vector and raster data, vector data comprises of various different representations. We get points, lines, polygons, and nodes. An example of point data would be a shop shown on a map. A line data would be a road shown on a map. Polygon would be an area of land use, such as a farm. Nodes are the beginning and end of line data. Then if we look at raster data, this consists of pixels from satellites. The GIS components: hardware, software, methods, people, and data. Data capture process used by GIS. Firstly, collect the data, standardize the data so that it can be shared. Capturing the data is costly, thus data is shared to reduce costs, which then leads to interpretability. We can either share it via the internet, network, application, or OpenStreetMap. OpenStreetMap is obviously the most common base map used in GIS. Then if we look at data protection, often this data is shared as read-only data, i.e. the people that receive it cannot write or edit the data. Then if we look at data integration, this is where we put multiple layers of a map produced in GIS together and combine them for a desired purpose. And basically what this comprises of is you'll have your OpenStreetMap, which forms your base map. Then you'll also turn on your river layers, your road layers, your main town layers, and all of these combined is known as data integration. So you're integrating all of the layers together. Then if we look at buffering, also a very common term that they love testing on, and you're required to know a bit of application around them. Generally, new features whose boundaries are a constant distance from original features. So buffering is an example of polygon data, and how they might test you in this is they will give you a river and they'll say draw a 2-kilometer buffer around the river, which will indicate the area where there is no development allowed, in order to protect the river and the surrounding wetlands on the banks of the river. So you would generate this buffer zone, and obviously you would use your map scale in order to get it into a real life distance. Then if we look at querying of data, query is a search to find features that are needed. Statistical analysis, attribute and spatial data can be analyzed in a spreadsheet. GIS uses security, disaster management, infrastructure, development, planning, and conservation. Then if we just look at some of the problems with GIS, no need to explain them. It's just the differences in how people interpret certain geographical features on GIS. Data collection can be an issue because of lack of signal in certain areas, etc. And data safety, that prevents, obviously, looking at people trying to hack the data, etc. That concludes the video on GIS, which forms part of the geography syllabus and can be tested in both paper 1 and paper 2. Thank you.